right? So the guy next to you is late, next to you might be your employer in the future. So perfect. Anyways, Armando, here's your.
Oh, awesome. Hey guys, my name's Armando. I'm the technical director for a company called Haven Agency. We're a digital marketing agency out here in Rancho Cucamonga. We work with the gaming and entertainment industry. So we do a lot of stuff with Riot Games, Blizzard, Bethesda, things like that. So today I kind of want to give you guys a brief introduction to SQL and relational databases. So have any of you guys actually worked with like a relational database before? MySQL? Sweet, awesome. So you guys have kind of a general idea. So this is a very basic introduction. So if you know a lot of the basics of SQL, this is probably going to be kind of boring, but I'll try to make it as entertaining as I can.
That was a good review.
Yeah, hopefully it's a good review for you guys. So I just kind of wanted to give anyone who's never touched MySQL or SQL before the opportunity to kind of mess around with it, learn the inner workings of it. Hopefully I can fill in some holes if you guys have any from what you guys have been using. At the end, if you guys have any questions, I'll be here. You guys can ask me whatever you want or tell me how bad I did. We'll see how we go. So with that being said, let's jump right into it. So the one thing I kind of want to start off with is the difference between SQL and MySQL. And a lot of people know that there is a difference. Yeah?
I'm sorry, I couldn't follow along right. How do I log into the presentation?
There's a link to Google, to the Google Slides. You should be able to just click that and follow along. Or is it asking you for something?
It's on Slack.
It's on the Slack channel.
Yeah, I don't think there's any login, right? I should have left it open for everybody to just...
You could get it hooked up.
Cool, okay. Oops, I went way too far. Everyone ignore those
I
slides.
jumped on you.
Ignore that slide. All right, so I'll keep moving forward. So the difference between SQL and MySQL is it's actually what's called a relational database management system. So SQL is the language that it uses, which SQL stands for Structured Query Language. You're going to hear it be called SQL, SQL. I call it SQL because I'm lazy, but the accepted term is SQL. So SQL is a query language. MySQL is the management system that's utilized for your query languages. There's a lot of different management systems. A lot of people, aside from, I should have locked it. Sorry. A lot of people will use like Oracle, for example, or if you're on the Windows tech stack, you're going to use MS SQL or MS SQL Server. There's also things like Ingress or whatever. So basically, we're talking about SQL, which is the language that's utilized across all those management systems. There's different variations to it, and certain systems have proprietary languages and helpers that they're different. We're not going to focus on those, so we're not going to focus on things like T-SQL or PL-SQL or anything like that, just pure SQL today. So as I mentioned, SQL, Structured Query Language. So it is a language, but it's mostly declarative, which means that we're not actually giving instructions on how to do something, we're just telling it what to do. Get me this, right? If you have kids at home, you're telling them, hey, go get me the toilet paper from the pantry. Like, they'll know to go get the toilet paper from the pantry. They might ask how or why. We don't care about it. We just want you to go get it and bring it back. That's what SQL is. So it's just a series of declarative instructions that let us know like what it is. I mentioned before there's things like TSQL, PLSQL. We're not going to worry about those or stored procedures. Those are for later topics down the road. The most important thing about SQL is to kind of break it down into components. So MySQL can be broken down into 4 major components, technically 5, but we're going to ignore the 5 one for now. So the 4 major components that we're going to talk about today will compromise the language itself. So we're going to talk about DDL, or data definition language. We're going to talk about DQL, data query languages, DML, data manipulation language, and DCL, which is the data control language. You guys don't need to worry about it too much. I'm going to break it down for you as much as I can here. So let's start off with DDL, our data defining language. These instructions are what's going to allow us to manipulate the data, or the tables on the database. We're going to create tables, we're going to alter tables, we're going to drop tables. So that's kind of what we're going to be focusing on. I have 3 down here. This is for, we're not going to talk about these too much, rename, truncate, and comment. Just know that they exist, and we're going to kind of ignore those for now. I forgot to remove it from the image. Right now, today, we're going to focus on create, alter, and drop. So this DDL, or this data defining language, is allowing us to create the tables that we're going to use in our database. DQL, which is the data query language, is what we're going to use to define our queries, how we're going to select the data. We can select all users. We can select all users with an ID between 1 and 100. We can select all new users. etc. We'll go into breaking down these SQL queries and the SQL query structure later on. The DML, or data manipulation language, we use to define or to bind modifications to the actual tables or the actual columns within the database. So I want to update a user status from 0 to 1. I want to change their name. I want to remove that user. I want to insert a new user. This is what the DML language or the DML component is for. And then the final one, which we're not going to get too heavy into today at a later time, is the data control language. And this gives us the ability to control who and how many databases someone can see. We're going to grant and revoke those privileges. If you've ever worked with SQL in the beginning, if you've ever worked on the command line, you've done something like grant all privileges to, X at localhost or whatever. You're giving the permission to that user to use something. Like I said, we're not going to get into that too much. Just know that it exists and it's a pretty important part. I did mention that there's a fifth secret one, which is TCL, and that's a transaction control language. This is kind of, I didn't include it here because it's not something that's really present. A lot of people mix it in with everything else, but I feel like it should be separate because the topic's a little advanced, and that's the transaction control language. When you're dealing with things like race conditions or inserting and manipulating multiple records at one time, you might run into an instance where I'm editing a user at the exact same time someone else is editing a user, wires get crossed, and you get garbage data. So the transaction control layer allows us to do things like block or stop access or write access to a particular table or reserve it, things like that. We won't get into that, but just note that that's another thing that exists. So this little chart here kind of gives you a breakdown of the SQL commands and what everything is. Later on, towards the end of this presentation, we're actually going to write some SQL commands, and I'll explain and break everything down as we get to it. So the big topic for a lot of people is the difference between SQL and no SQL. And so no SQL doesn't mean no SQL. It actually means not only SQL, right? Because over the last 20, 30 years, or since the inception of SQL, was it like the 70s or something it was invented? Since then, technology has advanced. Things have moved on, and we've had different ways of doing things. For a long time, people thought they were better, but as we kind of matured and as a lot of people in their careers moved on, they've realized that it's not that there's an improvement or a replacement to SQL, it's just now there's not only SQL. So with that being said, there are many differences between the two. And this topic isn't going to, or this presentation today isn't about what's better. It's not about if SQL is better, no SQL is better. This is just kind of to break down and give you guys a better understanding of what the difference is, so that when you guys move forward with your own projects or at work or whatever, you guys have a better idea of what might be better for you in your project moving forward. So one of the major differences is the language, right? I mentioned before, relational databases use something called SQL. And this is a structured language. It's predefined. We can't modify it. We can't create new functions. We can't add to it. We get what we get, and we can just stack it, do whatever we need to do. It's incredibly rigid. It's safe-ish, right? Because we know what to expect. If I'm going to pull a user from a users table, I know that that users table is going to exist, or it has to exist for me to pull that data. Something like no SQL, it has no defined schema and no structure. It's undefined. It's the Wild West. It can be whatever you want it to be, whatever your heart's desire. If you have a users table and you want to add an address, you don't have to predefine the address. You can just add it and it's there. So this is great for data that's constantly changing or always dynamic. But we'll get more into that a little bit later. So the best way I can describe the differences between relational and no SQL, so let's look at it this way. A relational database, we're using SQL. We live in a society where we pay with rocks, right? Only rocks. These rocks are predefined, the color, the shape, everything is predefined. We can only pay with those rocks. So if I go to somebody and give them 4 rocks, I'm going to get 4 rocks back because that's what's expected of me, right? If I decide to go and pay them with glass, they're not going to know what to do with it because it's going to bring society to a halt. Everyone's going to freak out because we only ever know that rocks are the only thing that we ever use, and that's it, nothing else, only rocks. So if I bring in glass, it's going to freak out, right? In contrast, if we go to like a no SQL world, well, I can pay with rocks, I can pay with seeds, I can pay with glass, I can pay with paper, whatever I want. I can create a brand new method of payment, and that's it. It'll work. There's going to be someone that's going to accept rocks, seeds, papers, and I can just define it as I go. So there's no defined structure, but imagine the chaos in a society where you can just pay with whatever you want and define it later. So that's kind of one of the major differences between SQL and NoSQL. Another one is scalability, right? Who here is familiar with scalability, or vertical and horizontal scaling? So we have the difference, right? Vertical scaling is you just throw more RAM and more CPU and more SSD onto a server and then hope that it stays up. Right. Then with SQL uses something called horizontal scaling, where you just shard it out or you create multiple things, right? So if you guys don't really have a general idea or best understanding for the difference between the two, is vertical scaling is I know exactly how many people are going to move into my city. I know I'm going to get 1 million people in 1 year, and then I'm going to have a 5 or 10% increase every year for the next 10, 15 years. I can kind of build it out, I can structure it and think, okay, I can build apartment complexes and then build floors and then add more floors if I need to. And then if that apartment gets too tall, I can build another apartment and scale up as much as I need to, because I know that I can pre-plan, because I know kind of generally what the approximate number of data is I'm going to get. NoSQL, on the other hand, we have no idea how many people are going to move into our city. It could be 10 people, it could be 10 million people, it could happen overnight, it can happen over 5 years, we have no idea. So rather than build up and rapidly increase our apartment complexes and rapidly add floors to it, we can just build houses that everyone's just built, that everyone lives in, and if we need more houses, we just build more tract homes and we keep building it out. We don't have to worry about, structural integrity of our apartment complexes, building them too high, or overpopulating a city with a bunch of apartment complexes. We can build 10 houses or we can build 1,000 houses. It's all the same template, it's all the same thing. We can just build it. We don't have to disturb any other house around it. We just build, as much as we need to. So that's kind of a general idea of why people choose vertical scaling versus horizontal scaling. I don't want to go too much into that. That's just kind of wanted to explain that. So the other thing is, one of the final differences between MySQL and NoSQL is schema. I mentioned before, for SQL, it's all pre-structured, it's predefined. So SQL is a safe bet for anything in regards to, if you want to have something that's safe and secure, you know what it's going to be. I mentioned before, if I ask to see a table, I expect to grab a table. So I can get the name, I can get the email, I can get the password from that user at any point in time. But if I want an address field and I don't have an address field, I'm in trouble. I have to define that first, because that's how we maintain normalization of our data. NoSQL isn't normalized and it has no schema. So essentially what we're doing is we're just throwing everything in, hoping that it works. And if it doesn't, we'll add it later. It's dynamic, it's meant to constantly change. It's good for big data, right? Like if you guys have a huge data structure and you guys need to rapidly build up your data, it's perfect for that. If you guys...
How do you keep it synced?
With
NoSQL.
With NoSQL?
Yeah.
Well, so each shard is an entity of itself. So it's a replication of the first shard. So if you have your first master, and then you shard off from that, it becomes a representation of that initial shard, and that data itself is isolated, so it's pulling off and resharding. I don't want to get too much into it because this topic isn't about scalability and the inner workings of how that works. But essentially, you take one copy and it copies it over, and then it syncs it, whatever system you're using it. It's I don't want to get too far into it because it's not really a part of the SQL talk, but we can talk about it a little more in detail a little bit later. So with that, which is better? I mean, there's really no difference. For some people, the definition comes down to, well, they know what they like, they learned it, never going to change my mind, ever. That's just what I'm going to use. Other people, they learned it, so that's what they use. They didn't learn anything else. For other people, their tech lead told them to use it, so that's just what they're going to use forever. They don't have any question. And then you have other people who, they built the application in it, had no idea what the difference between SQL and NoSQL was, and now at this point they're too far in to change it. Now they just got to make it work. The final piece is, of course, you think about it, you figure it out, you plan it, you study it, and hopefully you make the right decision based on your research. So with that being said, let's jump right into SQL. Sorry if that went a little fast. I wanted to get right into the nitty-gritty of everything, and I wanted to kind of give you guys the opportunity to mess around with some SQL. So let me just switch up my computer here and I'll open up my stuff. All right. So close this out here. All right, so I have some pre-prepared SQL. I'll go ahead and explain this, and I'll add this to the Slack channel later so you guys can play around with it. But I did this to save some time. We're going to do some other structures later, but basically what I've done here is I've created 3 tables, where I've created a database, and I'm going to be creating 3 tables that we're going to use. Those 3 tables today are going to be users, owners, and orders.
Can you
So,
zoom it in?
sorry?
Can you
Yeah.
zoom it in?
Oh yeah, sure.
Sorry, it's just tiny.
Is it super tiny?
There's a magnifying glass right at the top that might work.
Magnifying
Oh,
glass.
on the
In your
toolbar in your.
Here?
of the window.
Where are you guys seeing this magnifying glass?
Left.
To the.
Move your mouse down and about.
Oh no, this is a search.
Oh, is it a search?
Oh.
Yeah, it's a search. I should have, out of everything that I decided that I was going to test, I forgot to test how to make it bigger.
In the touch screen, can you just swipe to zoom?
Nope.
So you're gonna make this available later, so that's okay.
I'll make it available later. I don't want to take up too much time. I'll throw it in there. But so basically, what we're doing is we're creating 3 tables. And one thing I can do is I can actually draw it out later. But we're creating 3 tables: users, owners, and orders. Like I said, I've already created our table just to save time. So we're going to go ahead and manipulate it. So what I'm going to do is I'm going to select all from users. This is our first command. If you remember before, I mentioned that we're doing our data query language. This is the most basic of basic SQL commands that you're going to have. So what we're doing is we're saying select, and what this little asterisk here is it's telling us we're grabbing every table or everything from the table. Grab me everything. Give me, if there's 1,000,000 rows, get me all of them. I want everything. And we're saying we get that from the users table. So if I run this command, oh, I actually have to connect to a database first. That would help. So if I, oh, there we go. How did I do that? Is that big enough for you guys?
You just deleted everything.
How's that?
If you could zoom more, would be better.
There you go. How's
There
that?
you go.
That's as big as I can get.
That's good.
So what we're going to do is we're going to use our database. So we're going to use this database here, local test. And then again, let me rewrite this new. So this command I mentioned before, it's a query command. We're asking for everything from the users table. Just to reiterate, this asterisk here is signifying like we're getting everything. I want everything from this table. And we're saying we want everything from the users table. So if I run this command, it's going to give me, I don't know if I can make this any bigger. Doesn't look like it. So we're getting all of our users or all of our tables here. So we have all of our all of our users in this table. So let's say I want to get all of my users that have a status of 1. So you'll notice that some here have status of 0, and we have 2 here that have status of 1. So if I say select all from users where status equals 1, and I run the command again, I'm only going to get 2 because we have our status of 1. So how do we, let's try doing a couple of things here. Let's insert a new user, right? So we're going to jump into the DML, or the data manipulation language component of MySQL. Let's insert. So what we're going to be doing is we're going to be inserting. We're going to say insert into users, and then we have our fields here. So when we define this here, this parentheses, or inside this, the parameters that we're accepting are going to be the tables that were the columns of the table that we're going to be defining. So we want to insert into users, and we want to insert a title, because that's what we have. We want to insert a first name, a last name, an email, and a status.
Is it automatically set to ID, like to auto?
Yes, so the beginning, the ID here is auto incrementing. If we go back here when we created this table, let me see.
Oh, I said auto increment.
Yeah, so when we created the users table, we set the ID to a big int, and then we set it to auto increment and as the primary key. I'll explain what a primary key is in a bit here. But you can see here we've defined it as an auto increment, so whenever we create a new record, it's going to automatically increment that ID by 1, however we set it. You can see we set the title as a varchar, everything's varchar. When we're setting this as a default as a null, we're letting the database know that this field can be nullified. It means we don't have to do anything with it. If I don't go into this query, and if I don't provide title, it'll be fine because it's gonna default as null. So right now we want to put everything in there. So we have our first part. The first part of our insert structure, or insert query, is we're saying insert into users. We're going to insert these tables, and we're going to define our values on the next line. So here we can define values 2 ways. We can do a single record, which we're going to do right now, and then we can do multiple records, which I'll do right afterwards. So what we're doing is we're creating values, and inside these parentheses, we're going to be providing the values or what each of the insert tables are what we want them to be. So we have a title. So we want to set this first title. Well, we'll make this person a doctor. We'll set the first name. We'll do, I don't know, Kathy. We'll do our last name. We'll do Smith. We'll do our email. It's going to be ksmith@test.com. And then we're going to set her status to 1. So we actually, we missed one more thing here. I forgot. Username. We got to add username as well. So right here, we'll go ahead and we'll add our username. We'll just say her name is K Smith. So here we have our user. We have our insert query. We're inserting into title, first name, last name, etc. We're inserting the following values. These values can be anything as long as they match the data type that we've defined in the database. So because this is a varchar, this expects a string of a name or a first name, last name. If we try to put like an int, like a 1, it's not going to work because the data type doesn't match. And this is where
It would just treat it as a string, wouldn't
it can't, but just as an example, if you try to insert
quotes, though.
Yeah, it would have to be quotes. If you put an integer in as a single numeric value, it would define it as an integer, and it's not the same data type. And that's one of the things one of the gotchas of MySQL is that you would think that 1 equals quote 1, but it really doesn't in context of what the data type is. So yeah, so whatever the data type you define here is what the data type that you expect in your query. So because here, we'll go ahead and we'll run this, and we'll see that if we do this, you'll notice if I select all from users now, whoops. If I select all from users now, you'll notice that I added her twice. I didn't add a unique constraint, so forgive me. Always add unique constraints when you create users, so you don't have that. So we created our Dr. Kathy Smith.
Just gonna show us how to drop it now.
Yeah, exactly. We'll go into the drop.
There's 2 different the primary keys, right?
The primary, yeah,
Because it auto increments, and you just added a different one, so.
Yeah, so because it added a new record, you'll notice that the first record I inserted has a unique ID of 6, and that auto incremented to 7. So even though there's a unique constraint on this, like I should have a unique constraint on the email. The email should be unique in the database because I don't want to have Kathy to have 7 different usernames. I didn't do it for this tutorial or for this presentation, but just moving forward, don't do what I just did. Always add unique constraints. Anyways, so with that being said, we have a new user here. Now, to mention before, let's go ahead and change something up here. I mentioned before that this varchar, it has to be a varchar. So if I try to do an integer and I try to run the query command, it actually converts it to a string. So just kidding.
That might be my SQL thing.
Yeah, it might be that. But generally, if I'm trying to add a non-data type into it, it's not going to work.
Yeah.
Well, it converted it to a string, so
Right,
it's not the same thing as you have up there.
Right, it's not the same because it converted it to a string. Exactly. Generally, if you're trying to add a non-data type in a programming language, like you're trying to set something, it's not going to work because it's going to be you're submitting it in as a string. If it autocorrects it, it's still not the right thing because a string of 1, 2, 3 is not the same as a numerical value of 1, 2, 3.
Yeah, SQL Server doesn't allow that.
Yeah, exactly. So again, it depends on the management system that you're using. Everything's different. Everything, no matter how you're doing it, there's always different ways to do it. But at the end of the day, if you try to put in a title of doctor or title of 1, 2, 3, and you're expecting a string, but you get an int, your application is going to crash because you're getting the wrong data type.
Right.
It's one of the things of it being super strict. If it converts it, this is actually bad because then it looks like it's a false positive.
Kind of surprising that they
So
don't put that in
yeah,
there.
that's actually really surprising to me. I don't use my SQL Workbench too much in terms of the GUI, but if they convert it, they convert it. They should not be doing that. That should not happen.
Yeah, I think it will surely fail the other way around. So if you try to put a string into an integer,
Yeah,
it'll
crash as well. Yeah, that'll for sure crash. So we showed how to do one. So how do we do multiple, right? Because you don't want to keep doing this, make 7,000 different records. So if you want to do multiples, what we can do is we can go ahead and drop this down. Actually, let me take that whole thing here and let me copy that. So it's not much different. The only difference is you would just add a comma and you would add another record here. So you have 2 records here. So let's go ahead and let's change this back to doctor, and then let's change this person here also to Mr. And then let's change Kathy to Alan. So we'll change that. So now, and we'll change this status to 0. So what we're doing here is we're taking the exact same insert query and we're adding values to it, but what we're doing is we're defining 2 separate values. So what this is going to do is it's going to actually insert 2 records. So if you look back, we'll now have our Dr. Kathy Smith and our Mr. Alan Smith. And you can do this as many times as you want. You can add 50,000 records, whatever. As long as your computer can handle it, you can do it. So if we go back to our first title here, we'll go into inserts a little more in detail another time. So if you look at our record here, record 8, you have Kathy Smith with a title of 1, 2, 3, 4, 5. Obviously, that's not what we want. So let's move into actually updating it. So what we want to do is we want to take the record and we want to update it. So what we're going to do is we're going to say update. Oh gosh, what is it? Update what users table? I forgot what my users table is called. We're going to update the users table. We're going to set the title, and we're going to set that to Mrs. But we don't want to do this and update this on everything. We want to specifically target the one record. So what we want to do is we have this ID. So we can say where ID equals, what is that? 8. So what we're doing here is we're saying, hey, update this table. We're going to set the title on this table to Mrs. I don't want to define every title as Mrs. I only want to update this specific record with this specific ID. So if we run this again, you'll notice that our record of 8 has an update of Miss Kathy. So that's a basic update query, and that again falls into the same line of our DML or data manipulation language. So now we notice we have a bunch of different Kathy Smith records, so let's delete a couple of those. One of the things that we can do is we can delete. Now there's a big difference between delete and drop. If you don't want to drop, we're not going to get into that. We're only dealing with manipulating the specific data within this table. So what we're going to do is we're going to delete, so I can spell it right. We're going to delete, oh God, what is it? Delete from users, I think? Delete from users.
Is it
Where?
delete star from users where?
No, it should be delete from.
Where
I guess we can delete
title
everything.
equals miss or something?
Yeah. Well, we're not going to delete all the misses because then we're going to delete all the misses. We don't want to do that. So we're going to delete all from users where we want to delete it by an ID, right? So we can do it one way. We can go to where ID equals 7. 7, not 8. And it'll delete our record. Oh, wait, no, it should be. Yeah, there's no star. You don't need to put a star there. So delete from users where ID equals 7. So you can do this, and let's say you need to delete 100 records. Do you really want to do this for 7 records? No, I don't want to do it, and it's the wrong way to do it. If we can do something where we can loop through it, let's loop through it. So we'll notice here that we have a bunch of Kathys from 6, 8, and 9. So we can say where ID, and rather than say 8 equals a particular number, we can use this end command, and we can create a parentheses. And what this is doing is they're saying that we're going to delete all the users, or we're going to delete everything from users where ID exists within this, I guess you can call it an array or a collection of IDs. So let's delete 6, 8, and 9. So by running this command, what we're doing is we're saying take ID 6, 8, and 9. What we're going to do is we're going to remove everything from this table within this string of, or this collection of IDs. So if you run that, you'll notice that all 6, 8, and 9 of our records are deleted. The same in keyword or the same in command can be used to update content. If you want to update every user to true or false, then you can do where in one through and list through every single ID. This is great, and this is a good opportunity for you guys to, yes.
Is it changing the primary key when you add one now? Like, is it reusing the deleted keys?
No, it's not going to use the deleted key. What it's going to do is it's going to reserve that. That key is permanently reserved. It's been used. You don't ever want to recycle a key unless you're completely kill the database and start over from ground one. Whenever you're auto incrementing, whatever key has been used, that key has been used. It can never be used again. If you do use it again, you might run into some problems.
Some kind of ghosts.
Yeah. So what's going to happen is if I delete 6, 8, and 9, and let's say I didn't have a record 10 and it just went 5, and I deleted 6, 8, and 9. What's going to happen is the next record is actually going to be 7. Well, if 7's already deleted, then it's going to be 10. So it's going to go 5 to 10. So that's what'll happen. In the back.
Is there a shortcut, or if you can have the people with the concurrent
I'm sorry, I couldn't hear you.
Is there a shortcut if like you want to delete 25 IDs?
Like just delete 25 random IDs.
Yeah. Like, will you do manually there, or do you have like some kind of shortcut?
You can use conditionals like you would in a programming language. So you can say where name equals Kathy and title equals Mrs. or something.
So you can use conditionals to go through and like loop through certain things. I'm not going to get into that kind of stuff because that's a little more advanced for what I'm trying to do. But there is a way where you can go in and create a SQL command or a SQL statement that'll go through and take 25 random numbers and delete them, or get the first 25 out of X amount of records and delete them. There is a way to do that. I don't want to get into that because that's going to open up a rabbit hole of a bunch of other questions. If I had 3 hours, like we would totally do that. But
You mean you're not going to be back next Saturday to continue?
we can do it next Saturday, absolutely, if everyone wants it. I'm not doing a horrible job, sure. But I only got 10 minutes left, so I'm trying to condense and concatenate as much as